For your assignment number 6 first problem. So in this figure you can see a wrench or a spanner of 10 mm thickness, and total length of the spanner is 200 mm, and it is loaded by a pressure of 2 Newton per mm along a span of 100 mm. So this is your pressure acting on this handle over a span of 100 mm. And material is also given, that is Young's modulus 2 into 10 raised to 5, and Poisson ratio 0.3. So let's begin with this analysis. So go to first ANSYS APDL, that is a classic model. You can solve this problem by using workbench also, but I am showing this on classic mode. It will take some time to open. There we go. We'll start the analysis. First of all, we have to select the type of analysis. So this is a structural type of analysis. So but instead of 1D is a 2D type. So go to element, add, and select the element solid in that quad 4 node 182. Okay, so in that you have to select the plane stress with thickness type. Okay, because your problem having a thickness of 10 mm, then you have to add that thickness in the real constant. Go to add, into this element you have to add the thickness, that is 10 mm, 10 mm thickness. Select OK. Now define the material properties for your problem. So structural, linear, isotropic, elastic isotropic. So Young's model is given is 2E5 and Poisson's ratio is 0.3. Okay. Now there is two method of creating the model. First is to draw the model in any kind of CAD software, and then you have to import that software supporting by the ANSYS, or you can convert that CAD file into IGS format and then import it into this ANSYS or workbench. Then other method is to create the same model by using key points and other type of functions given in the ANSYS. If the uh, if the model is too much complicated, you have to use the first method only. Okay, so this is a simple one, so I'm using ANSYS only, not using the CAD file. So first of all, uh, I will tell you how to start with this drawing. So this B point shown over here, so B point is shown over here. So this will, I will take this as a 0 point. So B point I will take as 0 point, and then I will use this as an absolute coordinate system, and then from this point I will create the key points and add the area into it. Okay, so one by one we will start. So first go to key points. So in key point, in active coordinate system, first will be 0 then second will be at x will be 0 but y will be at 20. Okay, then the third key point. So I have created this point, key point number 1. Key point number 2 is this 1, this will be 2, this will be 3, this will be 4. Okay, 1 2 3 4. So but you can observe that this is a taper surface, so it is not in a straight line. So I will take 0 here, then at this center line, and I will adjust this 25, by 2.2.5 value. So x direction, so length is 150 minus 150 actually, and this will be 22.5 to get the taper applied, and then x will be remain same, and this will become minus 2.5. I adjusted 2.5 so that I can get the taper. Okay, so this 1 2 3 and 4 I have created the key point. Now I have to add the area in between these key points. So go to area, in that arbitrary through key points, so 1 2 3 and 4. Okay, in this way I created this area. Okay, so if you're using a high-end laptop, this line will be visible straight. So I'm using a inbuilt graphic card laptop, that's why it is not so clear. It is just a resolution defect. Then okay, now this semicircle to create. So for that that is of radius 10. Okay, so for that I will use a circle in that solid circle. So x will remains 0, y will become 10, so for that center, and radius will be 10. So in this way I created this. I have to add these two areas. So for that I have to go to operate booleans. So there are different types of tools available here: intersect, add, subtract, divide, glue, overlap, partitions. So we have previously used glue. Now we have to use the add to add these two areas. So area, this one and this one, I have to add it. Now it becomes 1. Now for this head of your wrench or a spanner, it is of I will create two areas. Suppose this is area to be removed, and this area number 2 is to add. Okay, so I will create this area, and I will create this also, and then I remove this first area from this. Okay, so for that I have to create different key points. So I will create first this number 1, then this 2, then 3, 4 and 5, and I will take 1 and 5 more than this length than it is shown in the figure, because to it will easily remove the material from that. So I am not to keep the material, that's why I am taking this length more compared to the dimension shown in the diagram. Okay, so 1 and 5 should be more, so it is of total length 195 from this origin. Then I will take more than 195, so I will take 210. That will be sufficient for 1 and 5 minus 210, and for this I will take as it is. Okay, for 2 3 and 4. So go to again create and key points in active CS. Now I will start with the first key point here, 210, and then height will be 27.5. Okay, applied. Then this 200 x will change to 172.5 as shown in figure. You can see this. For this 2 195 minus this 22.5, you will get 172.5. So 172.5, that is important. Applied. Then for the third, the difference of 10 mm. Okay, 162.5 minus 162.5 you have to take, and 162.5 and y will become 10, then again 172.5, and y will become minus 7.5, minus 7.5 applied, and last one 210, minus 210. Okay, so last key point, select OK. Okay, so 6, 7, 8, 9 and 10, this key point I have created. Now I have to add this area in between this key points, similarly as in the previous case, through key points 6, 7, 8, 9 and 10. So in this way, if I plot the area, it will look like this. Okay, so I have created this area. Okay, now I have to remove this area by creating this circle. Okay, so this is of radius 30 mm, so from the center, that is 172.5. Okay, so again go to solid circle. X direction will be minus 172.5, y will be at 10, and the radius will be 30. 30 is the radius. Okay, so diameter 60. So in this way I created this. Now I have to remove the area from this circle. I have to remove the first area. So for that I will go to again operate, in that subtract the area. So first of all you have to select that area from which you are going to subtract. So I will take this area. I have to remove the from this area. I have to remove that the first area. So select OK, then select that area which you want to remove it. Select that. Okay, this area I have to remove it. So then select OK. Okay, in this way you can remove the material. Now you have to add again this two areas, this one and this one. You have to add it in this way. Now it gets added up. Okay, so in this way you have created all your model as shown in the problem. You have created all the model. Now uh, after creating the model, we have given the thickness, we have given the material properties, we have created the model. Now the next step is to uh, define the loading condition, that is the boundary condition to your problem. So see this, pressure is given of 2 Newton per mm, but it is over only a span of 100 mm out of this. Okay, so it should be, the pressure should be applied only over this. Okay, 100 span. So for that we have to divide your model, so that if I going to apply a pressure over there, this it will take this entire line, and the pressure will be acting on the internal, but I have to take only 100 mm. For that we have to divide this area. So how to divide it? First of all you have to go to work plane, in that offset work plane. So in that there is a offset of x, y and z, and then a degree is given. So you have to input these two datas. So x direction we have to divide in minus 100. Okay, then because in x direction it will move from this 0 0 to, it will move at minus 100 direction, then 0, y will be 0 and z will be 0. Okay, and in which direction, that is xy, yz or zx, so it should be in zx direction, 0 comma 0 comma in 90 degree angle. So select OK. So you can see this, the work plane, that is wx, wz and wy changes its position from 0 0 to here. Okay, now we have to divide this. To go, again go to operate and into boolean. In boolean you will get a divide option. So in that, divide the area by work plane. So it will divide the area from this portion half and this portion here. Okay, so for that, select the area first and then select OK. So in this way it's get divided. So from this to this, it is a 100 mm and gets area gets divided. Now you can uh, apply your boundary conditions and loadings over this. So before applying it, you have to mesh this model first. Go to mesh, mesh in that size control, manual size, then global size, no, not in global size, in that smart size, no, I think manual size, global area, sorry, manual size. In that area, pick the area, pick the area, select this area and this area. So I will take both the areas and I will divide this into two edge elements length. Okay, and then I will mesh it up, mesh this area, free meshing, select this one and this also. So it will divide it into the length I have defined it. Okay, you can take one also. So now again I will plot the area so that I can see this half line. Okay, now after meshing, go to loads, define loads and apply loads, structural, displacement. Now see your problem. So this surface should be fixed and this surface should be fixed. Okay, so it is this spanner can be used to remove or tied to your bolt. So it is in contact with the bolt head. So this surface and this surface should be fixed and you have to apply this pressure over here. Okay, so for that, go again here, displacement on line. So on line, so here this should be fixed or degree of freedom equal to 0. Select OK. Okay, now pressure. So for pressure, go to pressure, online, select this line. Okay, so over this line only it will create the pressure. So pressure of, it's a constant pressure, so it is 2 Newton per mm, constant pressure. If there is a varying, it will, you have to take, if it is varying, then you have to take this existing table or constant value. You can take here 2 and the another one which is varying 2 5, varying between 2 to 5 and all. Okay, so it is not varying, it is a constant value, that is 2. So select OK. So the pressure is acting over this entire span of 100 mm. Okay, so after this you have to go to solution, solve current ls, select OK. Solution is done. Now go to general process. So in this you can see that this is shown by a red line, so it is pressure is acting equally constantly over the span of 100 mm. Now go to plot results, control plot, nodal solution. So df solution, displacement vector sum. So this will be our nodal solution from deformed shape. So maximum deformation is 0.67 mm, and you can see by listing out list results, nodal solution, go to df solution, displacement vector sum. So you will get, so only take the snapshot of the first deflection value and only take this maximum absolute values. It is a 0.67086. Okay, so this is the maximum at node number 53. It is a maximum. Okay, so in this way, for taking the right meta file and invert black and white. If you can see this, should save in where it is set. Again, I will save it. Plot control, right meta file. It is in 01. It is in documents. Okay, it's in documents. Go to documents. I think this one. So this will be your answer. So take a print of this, and then the print of the list results. You have to take this question also. Okay, take a snapshot of this and use it, or you can draw it on a journal papers. You can draw this problem and then take this snapshot print, and the answer print is this in this way. Nodal solution, the answer print, just take the last this answer, maximum absolute values. Okay, so take this uh, over that page only. So this is your first problem for assignment number 6. The second problem I will upload it till by Tuesday. Okay, so stay tuned for the videos lectures I will uploading tomorrow. We will continue with the linear interpolation problems and completing the linear interpolation analysis, and then we will go ahead to this type of plane stress problems of quadratic elements, then plane strain problems and axisymmetric problems to cover the unit number 4. Okay, so till date I have covered 4 unit and I have started the 5th unit. uh, Covered the four unit and started the 5th unit of 2D finite element analysis. Okay, so stay tuned for more video lectures. Thank you.